Happy New Year and welcome to another episode of Lexx Education. It's the gloriously 2025 podcast where comedian me, Laura Lexx, tries to learn science from her non-comedian but equally 2025 brother Ron.
Wow. Starting off mid in the new year.
Do you know what the problem is, Ron? Is as I was setting up and getting ready for today, I thought, wouldn't it be cool to call you Rongelina Jolie at some point today? That's cute, right? And then through the whole of that intro, I was trying to work out where to slide Rongelina Jolie into the conversation, and it never panned out. This is why some people script stuff, but I just like our flying by the seat of the pants, loosey-goosey approach.
Well, I could be Ron Voight. And then I guess you'd be Angelora.
But you're not my
basically,
dad. No.
Agony John Voight.
You're not helpful in any way, Ron.
No.
We should do another Agony Dad episode.
Yeah, we should. I haven't had agony.
Apologies for my dying, by the way. I will edit out the coughing, but the nose cannot be stopped. Illness is in the Lexx household. So is barking. I've done one of the most Laura things I've ever done. It's annoyed Tom.
Did you spend an exorbitant amount of money on, I don't know, is it some kind of cream for your elbows?
No, I got loads of those in my advent calendar, and actually I've got an oil for my elbows now, and you can barely tell that they're elbows. The skin on my elbows is just like any other skin. It's wild.
Show me. Oh yeah.
Look at that. There's nothing there. I'm just. If it wasn't for the bone, you wouldn't even know it was my elbow.
Sometimes I get.
Not that the skin is the main feature of your elbow, but
there's a word for the skin on your elbow that's funny. It's called like a gingus or something. Hang on.
Ugh. Well, we're not sponsored by them, but the Aveeno body oil that I got in my
a weenus
calendar this year.
It's called
a weenus. You can't
it's
call
called
it a
your
weenus.
weenus.
Well, my weenus is supple and smooth and barely feels like a testicle. No, I'll tell you what I've done, Ron, is we got a new calendar, 2025. It's currently the 2nd of January when we're recording this. And now that I'm a grown-up mother with a family, we've got one of those ones with columns for everybody,
nice.
You know? And so I gave Mackie a column, and then Tom was like, why have you done this? She doesn't have any plans. So I've written plans for Mackie on every day of the month. Most of them are barking, but some of them are cuddles or sniffing. It's one of the stupidest things I've ever spent 15 minutes doing. And I've done this for like 4 years.
Did you start out like the first week of January? It's like barking, cuddling, walkies, taking a poop, and then about the 12th of Jan, then you're just barking.
Yeah. There's a long stretch because when we stay overnight, we like where we're going or whatever, and then just do an arrow across whatever days we're away. So I have done barking for like a week solid down near the bottom.
Yeah,
it's pretty good. Tom has suggested that in future months we put the babysitters that we have, rotating. That would be a more sensible use of the 4th column. But I like Mackie to be involved.
Yeah, she just needs to contribute.
Yeah, she does need to contribute. She's so cute. I saw the bag of bones over New Year too.
Oh, I missed the bag of bones.
New dog of the podcast. We looked after somebody's dog over Christmas.
We looked after the small ghost of a horse. And I loved it.
Lil Whippet. Man, she's amazing. How are you, Ron? Where are you?
I'm in Brussels at the moment. Came back to Brussels after Christmas because it was a friend's 30th birthday. So he threw a New Year's party, which was very, very lovely. Cooked some nice food, and it was like 12 of us or something. Pretty cash.
Like the apostles.
Yeah. And then yesterday...
Is that right? No, 4 apostles, 12 disciples.
Don't fucking start on this. There were 11 apostles, 12 disciples. They're the same people apart from not Judas.
Oh. Who were the 4 then that wrote the Gospels?
Yeah,
Were they special in any way?
They were just really good disciples, I think.
Oh, okay.
This is a tangent, but
The
Judith's...
whole podcast is a tangent.
Judith's parents have this game called Jerusalem, classic big board game, and basically the whole thing in there is you have to try and get lads into the Last Supper, and the closer they are to Jesus or the apostles, you get more points at the end of the game.
I don't want to meet the people that made up this game.
No, but then I was playing this, and then we had this exact discussion about the difference between disciples and apostles and stuff. So then I just started reading the Wikipedia page on Jesus Christ, and it turns out I knew fuck all about... Did you know he had brothers?
Oh, no.
I always just assumed he was an only child. No, he just
Half brothers, though.
Well, yeah, kind of.
Because he wasn't Joseph's kid, so...
Well, he was and he wasn't.
No, he wasn't, Ron, because for Virgin Mary.
Yeah.
Virgin birth.
But one of his brothers was called Judas, but not that one.
Different one.
Yeah. I learnt loads. I've forgotten it all now. But
because he potentially had kids. That's what the Da Vinci Codes was all about, isn't it?
Yeah.
He had banging time with Mary Magdalene. Because didn't really get up to anything until his 30s. Because there is some speculation, wasn't there? I vaguely remember half reading and then forgetting and misremembering. But there's some speculation that he travelled to India, potentially, and that mooching a bit of Buddhism in with Judaism is how he ended up at the Christianity. Because like the New Testament is so much more like chill and forgivey than the Old Testament, and it's potentially like influenced by different religions.
Yeah, that makes sense. So I guess people from there might have gone to him.
Yeah, but nobody really knows what he was up to for the first 20 odd years, 25 years.
But there are quite a lot of stories of that.
Of what?
Of his life. As a boy.
Oh, lovely.
Yeah. Stuff like there's, well, I mean, the thing is, how much can you believe any of this? Because it's all obviously propaganda and stories about him, like, as a young kid going into temples and debating the, I guess, rabbis and stuff that were in
the
there
Pharisees.
Yeah, but as a kid and understanding it all.
Well.
But why, anyway, but then, then it was New Year's Day yesterday. We watched Love Island while I got over my hangover, and then we went to a spa.
Wait, does your new computer still lock itself every 5 minutes?
This is my old computer because I have to work.
Ron!
Not the next record, because we're recording tomorrow. When I'm home, we'll be recording I'm not going to carry 2 laptops around with me.
Oh, then carry the good one, you idiot.
No, because I need to work.
Ugh, do you? Right, so go off and enjoy chemistry results, everybody.
Yeah, this is an intro.
Oh dear, she's dying again. Go do it before I have this coughing fit. See you afterwards. Bye. I revved my butt, ready for chemistry results.
Okay, Laura.
Can you please send me the thing again?
What thing?
The paper, so I can have a look at the paper.
Sure.
Got nothing in my brain.
All right, Laura.
Na-na-na-na-na.
This is
Yes.
Chemistry High Tier. How do you think it went, thinking back to it? Do you think you got better or worse
not
than
good.
biology?
Sorry, I pressed a button. I think
It's not professional,
worse.
Laura.
It's not professional. I think worse. I think I've got around 40%.
Okay. Well, so we start off with a question about structure and bonding. You were asked which 2 substances have intermolecular forces between particles. And the first one you went for was sodium chloride, so we were straight in with a whiff. Sodium chloride, clearly ionic. One of them's a metal.
Clearly ionic.
But one of them's a metal, sodium.
Didn't I change these answers? Because didn't you say that at the time and I changed it?
No.
I'm pretty sure I did.
No, it's not written down. So straight in with a whiff. And then the second one you went for was water, which was correct. But instead of sodium chloride, which we've talked so much about that being ionically bonded.
I pulled my headphones out. I'm sure we changed that in the moment.
Well, it's not written down.
Have you not edited it yet? Have you not listened?
No, I haven't.
I think, give me the mark for, was it polyethylene?
It was polyethylene.
Yeah, I think we changed that in the moment.
No, was that not when you were like, oh, just tell me now, it doesn't have to change the mark, I just want to know.
No, I'm sure you huffled and puffled at me at the time.
No, it would have been changed in here. So then question number 2 was basically you had to compare the structure and bonding between carbon dioxide, magnesium oxide, and silicon dioxide for 6 marks, Laura.
Sorry, bear with me a second. Ron, are you ordering rennet and pastry brushes through our Amazon?
I hadn't actually ordered them.
There's a load of rennet and pastry brushes in our shopping basket on Amazon.
Yes, they're in the shopping basket, but I haven't ordered them. I do want them.
No. That is Ron. Why are they in our basket?
Because you guys have Prime.
Can you buy... hang on, what's Tom saying? I think can you just buy them?
No, it's add to a later order. There's a button for that.
Ron says add to later order. Sorry, he is horrid.
I'm learning how to make cheese. I thought you guys would be happy about this.
Why do you need have you taught Child of the podcast about pizza ovens?
No.
She won't stop banging on about pizza ovens, and I don't even know how she knows what a pizza oven is.
No, that was not me. I don't talk about pizza ovens, to be honest.
Okay, right. Anyway, sorry, back to the exam.
Yeah, why have I started a timer? That's what we need for the exam, not for the results. So we're comparing the structure of carbon dioxide, magnesium oxide, and silicon dioxide. You said magnesium oxide has ionic bonds, where the other 2 compounds have covalent bonds.
Correct.
That is correct. This makes the bonding in the magnesium oxide the strongest of the 3. Wrong.
That's not true. That's the weakest.
Ionic is weaker than covalent. Carbon dioxide
It's like having a different brain.
Carbon dioxide and silicon dioxide both have covalent. Carbon dioxide is a more stable structure than silicon dioxide because there are no spare bonds. That's nonsense. Silicon dioxide has a more erratic structure of bonds.
Correct?
No, I gave you 1 out of 6.
Oh, fuck off.
Because you said one thing that was correct.
What else should I have said?
Carbon dioxide and silicon dioxide are made up of atoms, but magnesium oxide is made up of ions. Silicon dioxide and magnesium oxide are giant structures, but carbon dioxide is small molecules with weak intermolecular forces. All 3 compounds have strong bonds. Carbon dioxide and silicon dioxide are formed between 2 non-metals, so bonds formed are covalent. Electron pairs are shared between atoms, but magnesium oxide is formed with a metal and a non-metal, so the bonds are ionic. Electrons are transferred from magnesium to oxygens. 2 electrons are transferred. Bonds in silicon dioxide are single bonds, where each silicon forms 4 bonds. Each oxygen forms 2 bonds. In carbon dioxide, the bonds are double bonds, where carbons form 2 double bonds and an oxygen forms 1 double bond.
Well, I didn't know any of that.
Well, you should have. So that's question 1 done. Question 1 was short and bitter.
So what do I get? 2 out of 8?
2 out of 8. Yeah.
Oh, my 40% is looking unrealistic.
You then correctly identified that. Question.
That's 25%. Okay.
Question 2 is about metals and the reactivity series, and you correctly identified that 2 properties of transition metals are that they have different charges. They form ions with different charges, and that they have high melting points. So that was 2 marks for that.
Great. Well done, me. Sounds like I was very clever that day.
Now, here's one where this is where the wording starts getting really weird. So,
This is the thing, though, Ron. As soon as you see all these lines on the page where I just have to talk into the space provided, that's where it goes wrong.
yeah, that's where the bulk of the marks are.
Yeah, and that's why higher tier is much harder.
But it's just odd because
It's a bit like I'm a really good bowler when I've got the barriers out. Whereas if you just give me too much space, I'll get erratic and end up in a gutter. And that's how I feel about exams.
yeah, because easier things are easier.
Yeah.
So the question was, a student added copper metal to colourless silver nitrate solution, and they observed pale grey crystals forming and the solution turning blue. Explain.
I feel like I'd made some good guesses in this one.
Yeah, and spoiler alert, but you got all 3 marks, but I was very generous with the what you said about it. The question was, explain how these observations show that silver is less reactive than copper. You said, quote, "The copper reacted with the nitrate, stealing it from the silver. And..."
Don't put emphasis on it like that.
"And the silver was not reactive enough to hold on to the nitrate. We know this because of the observations the students saw. The pale grey crystals show the silver going back to being single silver and the solution turning blue, the signature colour of copper nitrate."
Is that right?
So, yeah, like I said, I gave you all 3 marks, and I'll put my hands in the air. I don't know if a proper marker would have given you all 3, but you definitely have gotten some. But, so that's what you wrote for this, right? Here's how it's written in the mark scheme. The grey crystals are silver, mark. The copper ions produced are blue, mark. Because copper displaces silver, mark.
Well, it's much less entertaining, isn't it?
It is, yeah, that would be a boring podcast.
I am the Hemingway of the GCSE world.
Explain. Because I don't think you know enough about Hemingway to pull this off. We should read Hemingway for book club. I've never read any Hemingway.
I was actually thinking of an Orwell.
As long as it's not
It's my choice
Animal
next,
Farm.
and I've never read 1984.
How long is it, though? Because we've got a 300-page maximum now. After the fucking...
No, we haven't.
We do after the 1,000-pager. And...
Nobody read the 1,000-pager.
Yeah, because it was 1,000 pages long, Laura.
But then don't be in a book club if you don't want to read pages.
No, it's very common to have a page limit for book clubs.
But not 300 pages. That limits it massively.
Right, 400.
No, stop pulling numbers out of your stupid wet butt.
What would you have, 2,000?
How many pages is 1984? No. Why does it... 328 pages in the original publication, first printing in 1949.
Probably allow that. Plus or minus 10% on the 300.
Ugh. There's just nothing wrong with a 1,000-pager book, Ron.
For a book club,
when it's
it's
a great
too
book,
long.
That's just more of what you're enjoying.
It was a bad book.
It wasn't a bad book. You didn't read it.
I didn't like it.
Because you didn't read it.
You didn't read it either.
I listened to it twice.
Anywho, a student...
Anyway, my point is, children's shoes, never worn, half price.
Yeah. Very laconic, Hemingway.
3 points.
Whereas you are the opposite. You're the anti-Hemingway.
No, Hemingway wrote Gatsby, didn't he?
No, that was F. Scott Fitzgerald.
Oh, okay. Maybe I'm the F. Scott Fitzgerald of GCSE.
Maybe you are.
What did Hemingway write?
Old Man and the Sea.
Best of times, worst of times?
For whom the bell tolls.
No, that was the Bee Gees.
The best of times, worst of times. Is that not the first line of, like, Great Expectations or something?
I don't know. Let's read that.
Oh, not Dickens.
Have you ever tried to read Dickens? It's incomprehensible.
Yeah, I don't want to read Dickens. Anyway,
No.
2.3, a student is...
Suck my Dickens!
Not good enough. A student is given 3 metals, X, Y, and Z to identify. The metals are magnesium.
I've identified them. They're X, Y, and Z.
Well, the next sentence is...
Wish I'd said
The
that.
metals are magnesium, iron, and copper.
I think I did well on this one.
Do you?
I remember thinking about it a lot.
Do you want to hear what you said? You had to plan an investigation, basically. Quote, get 3 beakers and put 100 ml of hydrochloric acid in each. Get out some goggles.
Sounds good so far.
Oh, sorry.
One mark.
Put some goggles on. Get some tweezers. Get some of Metal X and pop it in the first beaker. See if it fizzes. See if there's a fire. See if it changes colour. It does. If it does, that's magnesium. Put some Y in the next beaker. Have a look. If it goes blue, that's copper. Iron is the other one. Once you've identified 2, you'll know what that is. Save yourself a beaker. Stir it. Take goggles off. Go home.
Pretty good. Did it get any marks?
No.
Aw.
I couldn't in good conscience give you any marks for that. My only comment was really bad.
I don't know how to do that one, Ron.
No, it was really funny that you thought you did really well because you got cross and gave up.
I didn't give up.
Do you not think that's... Once you've identified 2, you'll know what that is. Save yourself a beaker. Does that not sound like giving up?
I think it sounds like logic. I think that sounds smart, scientific thinking.
Doesn't. 2.4, you had to calculate the relative atomic mass of metal M. I'll save everyone going through the maths. You got that right. So it's 7 for 9 on question 2, Laura.
Hello. 7 out of 9. Okay, so where are we now? On aggregate, we're on 9 out of 17, which is just over the 50% mark.
Question 3 is about silver iodide.
Oh, hang on a minute. Let's just roll around on page 7, which is a do not write on this pager.
Answer in the spaces provided. Yeah, it's all about silver iodide. I don't remember what happened in 3.1 because I've just written 2 marks dash big help. But you apparently got 2 marks for that one.
Oh, this one was all about the mass, Ron, and I spent a while doing
because you couldn't work out that the fucking beaker weighed something.
I did work it out, though, you little prince.
Eventually, with big help.
Yeah, you're meant to have been big help throughout this entire show.
How?
Maybe if you'd been more help early doors, I wouldn't need so much help now.
Maybe we should have done one of these beforehand. And then we could have seen your improvement, but 2.5 years too late now.
Maybe we should do that with A-level.
But that's going to be like 6 months of exams back to back.
Oh, Christ.
Laura, focus up.
Oh, God. Yeah, I'm focused.
You're not. You're on your phone.
I know. I've bought a sparkly jacket on Vinted and I'm very excited for it to arrive.
That's very nice. See, I can't believe I'm getting shit for buying rennet and pastry brushes.
Yeah, but I'm doing it on my own account.
Yeah, I'm doing it on your account. Our account.
If my husband ever leaves me, it will be because of you.
Yeah, but if your husband ever leaves you, he'll come and hang with me and we'll play Magic the Gathering and watch sirens take the island.
Yeah, that's true.
Anyway, 3.2 suggests how the student could separate insoluble silver iodide. You correctly identified they could filter it.
Yes.
Now, you're going to be cross about this next one, Laura.
Well, then why? Why make me cross?
So, it's not me making you cross. So it's 3.3 suggests one impurity that could be removed by rinsing with water from the experiment earlier on in the question. You said nitrate solution. The answers were sodium nitrate or silver nitrate or sodium iodide. And you also would have been allowed nitrate ions, but I couldn't in good conscience give you nitrate solution. But you were
Fine.
you were around it. And then, you correctly suggested that they would warm it to dry it out and get rid of water.
Your hair looks mad right now.
Oh, yeah.
You look like a real dork in an office. Ugh.
Then you worked out the percentage atom economy for it. I've got written in block.
In this atom economy?
I've got it written in block capitals. Lots of help on this one.
No. Lots of help from my big old brain.
But you did. You did get 4 marks because you got it correct. So
Yes.
well done there.
I think that was another one I came back to, wasn't it?
No. No, I've got the ones that you came back to in orange. We'll talk about those later.
Oh, okay.
Yeah.
I just smashed that one out the park at the beginning then.
With in block capitals, lots of help.
You don't know. I might have been having help moving house while I was answering that
I was
question.
there. I wrote this.
But memory is not infallible, Ron.
Mine is.
Nope.
Question 3.6. Give one reason why reactions with high atom economy are used in industry. Now, I really wasn't sure how to mark this one. You said it is more cost effective. The answers that were allowed were for sustainable development, for economic reasons, or to produce a higher percentage of useful product. So I gave you
Well,
the
that's
mark.
economic reasons.
Yeah.
Yeah, because that's economic reasons.
Yeah. Okay. Yeah. It's just I don't know. I'm not trained. I'm doing this weirdly as a
No.
hobby. I'm
Hey, Ron. Yeah, we understand. I'm not trained in science either.
yeah. So then we came on to the question that was about
So
electrolysis.
hang on, what did I get for question 3 then?
9 out of 10.
Hey!
Laura,
Bloody
you're
hell!
removing all suspense from the end by adding these up as we go along.
Well, I'm interested. I'm involved. Isn't that okay, Ron? Why don't we do it this way for this one, and we'll see what people think, and then if they don't like it, I shan't do it for physics.
Okay, that's fine. All right, question 4 is about electrolysis. You were asked to exchange why the colour of the liquid changed to the different electrodes. And you got 2 marks on that. You said the positive electrode attracted the chromate ions. They gathered at that electrode due to their negative charge being attracted to the positive charge of the electrode.
I tried to say specific things there. I tried to mention positive electrode. Yeah?
Yeah. And to be fair, the mark was chromate ions moved to the positive electrode because opposite charges attract. So I gave you 2 marks.
Hey, do you think there's a political science joke? Something about why are
It would have to be quicker than this in its delivery.
why are hydroxide ions attracted to Donald Trump? Because he's a negative elected chode.
Ugh.
A negative electrode? Something? Come on. No. Okay, don't worry.
You'd have to. I don't know what the setup would have to be.
Or the audience.
The gas produced.
I'll send it to Kamala Harris and see if she wants it for her after dinner speaking tour.
Yeah. You had to name the substance in the solution that provides hydroxide ions, and you said water, which was correct.
Banging.
Okay, then you had to describe why a solid forms of the negative electrode. Again, you got the mark for that one again, Laura.
Yes.
Oh.
All 3 of them?
No, you got 1 out of 3.
Oh.
Because you did not talk about copper ions gaining electrons. You suffered now for a while because you don't know what oxidation and reduction reactions are.
Yeah. I find that it goes worse when I don't understand it.
Yeah. So you said the positive copper ions are attracted to the negative electrode, and when they get there, they form magnetic bonds with each other and solidify into copper pieces. No such thing as a magnetic bond.
I think I meant metallic.
Yeah, but you didn't say that. And even worse, I actually
Possibly
wrote
you've
down
spelt that wrong.
magentic. So
Yeah, nice pink bond.
you then had a stab at what was getting produced at the different electrodes. You said potassium at the negative electrode. No potassium involved in this question.
Potassium iodide solution.
Where does it say that?
The student repeated the investigation using potassium iodide solution instead of copper chromate solution.
Oh, sorry.
Name the product at each electrode when potassium iodide solution is electrolyzed.
Sorry, you're right. But it still wasn't potassium, it was hydrogen. But you did get the positive one right, by chance probably. And you said iodine. Well done. 5 out of 8.
Not by chance, Ron. I just took the two things involved and wrote one at each electrode. 5 out of 8. Okay. All right. Let's not get scared, though. All right.
5.1, Laura, was about the development of scientific theories. You were asked
Okay.
to
I feel
describe
like I
three
did okay
differences.
here. This was a lot of logicking.
Now, you've run into a pitfall on this one, and you haven't done great. So, describe the 3 other differences between the nuclear model of the atom and the plum pudding model. And the mistake that you've made here is that what we think now isn't the nuclear model. The nuclear model is kind of like the first iteration of that's then been refined over the years.
Oh.
So you said plum pudding does not have any space in the atom, whereas the nuclear model, there is space between the electrons and the nucleus. You got a mark for that. That was good.
Yes.
You then said there were no protons in the plum pudding model. The positive charge is the atom itself. So while that is true, the nuclear model doesn't know about protons either. They hadn't been discovered when the nuclear model was... Like the nuclear model, think of it less of what we've got now and more like the plum pudding model, but instead of the negative plums being in the pudding, the negative plums are around the pudding.
Right. Yeah.
And we still think of the pudding as a thing. And then similarly, you said in the nuclear model, we understand the electrons to be in shells around the nucleus in a specific structure. Again, true, but that's a development that came later. So 1 out of 3 there.
Okay.
So Niels Bohr adapted the nuclear model. Describe the change that Bohr made to the nuclear model. You said he put the protons inside the nucleus.
Yeah.
But do you not see that as a weird thing to say? He put them there? It's very... And on the 5th day, Niels Bohr...
In his theory of it.
But no, and that's not what he did, I'm afraid. He's the one that electrons orbiting the nucleus in the specific distances.
Oh, well done, Bohr. That's quite a big deal.
Yeah. So the next one, this was genuine brain power from you. Mendeleev. Basically working out why Mendeleev wasn't arranging things in atomic number. You said,
Yep.
and this is the first one where I've actually written down, I said, you phrase things like a fucking insane person. Because you said, Mendeleev worked this out before protons were discovered, and you need to know the number of protons to know the atomic number. It's all just written like a wily sphinx by the side of a road. It's very weird, but it did get you 2 marks.
Yes.
For the 4th one, I remember us talking this through, so I just wrote correct -help. But you did get a mark for that, so you're 4 for 8 in that one, Laura.
Okay. All right. 50% still. Okay.
Question 6 was about displacement reactions.
Yes. Okay, I think I got this activation energy question right, though, didn't I?
You did.
That's the amount of energy required to start a reaction.
And that's the exact words you used before, and it was correct then, and it's correct now. Yeah.
Yes.
The next one, it just says 4 marks. Help.
Was this a comebacksy?
No.
Oh, no. This is...
Oh, show that aluminium is the limiting reactant.
Yeah. I remember this one. Yeah, it was working out that the aluminium would run out first.
Yes. And we talked about it for a long time, but you did get there in the end, and therefore you got 4 marks. You then completed the ionic equation for magnesium reacting with zinc ions, and you got magnesium ions and zinc.
Yes.
You then were asked to explain...
There's oxidation and reduction in this question, and I famously don't know what those are.
No, you were asked to explain why the reaction between magnesium ions and zinc ions is both oxidation and reduction. Do you know what you said?
Nope.
No, because you said, I don't know what oxidation means.
No, actually, I didn't say that. I was still thinking, and you said, I'm just going to write down, I don't know what oxidation means.
Can you tell me what oxidation is?
No, because I thought it was when oxygen mixes with something, and you said it wasn't.
It's not.
Well, there we go then.
And then we move on to question...
So what is it? You can't just leave us.
What's what? Oxidation?
Oxidation.
Gaining electrons. That's it.
Why is it called oxidation?
Because oxygen has lots of electrons. So when oxygen reacts with stuff, like when rust oxidizes, it is getting oxygen, but those oxygens are bringing electrons. And then it's kind of just appropriated that name for reactions that give electrons to stuff, because oxygen is a really common source of those electrons.
Right. Well, that's good to know.
It's good knowledge. Hold on to it.
All right, so 6 was pretty good. That was a lot of points. What did I get there?
6, you got 7 out of 9.
Oh, that's high.
Right, question 7. The reaction between oxygen and hydrogen releases energy. And you had to work out 2 errors with the reaction profile shown in this graph. Now, again,
Yeah. I don't think I did well here. I think if this one had been early in the exam, I'd have done better. But I think I was on Fizzlehead by now.
Maybe. Because, yeah, this one was rough for you. And if you hadn't come back to one later on, it would have been really rough. So we got... And again, weird wording, Laura. Overall energy change.
I'm a poet, Ron.
Overall energy change ought to go from the first line right up to the peak. Activation ought to be where the line starts to go up.
Why are you acting like saying ought is weird?
That is weird.
It's not weird.
It is weird. It's a weird...
What would you say?
Should.
Oh, those are the same.
Yeah, but one's weird and one's normal.
No, it's not.
Anyway, so you got 0 for this one.
Oh.
Because overall energy change is correct, because you see how it starts where it starts and finishes where it finishes. So that's the overall change.
You are a sanctimonious little prick sometimes.
And then the activation, what you could have said is, so then the other, the activation energy should cover the whole peak, is one where it only goes half, is one error.
Yeah, I said that.
No, you didn't. You said activation ought to be where the line starts to go up, as that's where activation starts.
Yeah. It's the whole peak.
That's not what you said.
That is the same thing said in 2 languages.
No. You ought to have said that, but you didn't. You talked about where it should have started rather than it covering the whole
Fine.
peak. And then the other thing that's wrong with it is that it says in the top of the question that this reaction releases energy, but in the graph, the products at the end have a higher energy state than the reactants at the beginning. So it's gained energy rather than losing it.
Oh, well, I can't be expected to understand that.
Maybe not. So then 7.2, again, a big whiff from you. You went... Now, I don't know. You were a bit unlucky with this one. So this was about comparing hydrogen fuel cells and rechargeable cells for electric cars or whatever. And you said byproducts from hydrogen fuels is just water rather than CO2, which is bad for the environment. You got 0 for this one because rechargeable fuel cells could be powered by renewables, so that doesn't necessarily release CO2. So
yeah, okay.
Bit of a whiff. The second one I do think you were just unlucky on because it says you said rechargeable cells require lithium, which has catastrophic mining implications. But unfortunately, just the environmental plea doesn't really come up in the answers that I've got, apart from no toxic chemicals to dispose at the end of the cell's life. So it was 0 on this one. I think if you hadn't named lithium by name, maybe if I was a proper marker, I'd have been tempted to give you...
So I know too much is what you're saying.
Well, no, because they don't all have to contain lithium.
I know too much is what you're saying.
It's not what I'm saying. You got 0 marks, Laura.
I'm too knowledgeable to score. I hear you, Ron, loud and clear.
All right, you take that. The next question was...
Question 7, I am eating dirt.
Write a half equation for a hydrogen fuel cell reaction. You just put H plus, arrow, negative electron. Which was not correct.
I don't know what a half equation is.
So, I don't know. There were 4 there. A half equation is basically when, rather than giving both reactants, you kind of just talk about what happens to one of them. So, the hydrogen one would have been hydrogen gas, H2, goes to 2H plus 2 E minus being electrons. So, in an actual reaction, those electrons are going to somewhere else. But you just talk about half of it in a half equation. Question 7.4 though, Laura. You got 1 mark out of 2 for that one.
To joke about there.
You got...
Oh, that's good.
Yeah, but again, just really weirdly written. Simple particle model is not pairs. But I did give you the point for that. So it was 3 states of matter can be the 3 states of matter can be represented by a simple particle model, and you had to give 2 limitations of that. I was a bit generous with this one, maybe, because it was any 2 from hydrogen is not shown as H2 / molecules. Particles are shown as spheres. Particles are shown as solid. Does not show the weak forces between particles, does not show the movement / speed of particles, is only 2-dimensional. You said simple particle model is not pairs. But I did give you hydrogen is not shown as H2, because I think you've shown the understanding there. You've just written it like a genie. Next one was hydrogen gas needed to power a car would occupy a large volume. How could you reduce that? You said have it in liquid form, and that was absolutely right. So you got a mark for that one.
Yeah! 3 whole marks.
We're at 2 marks so far.
No.
Yes.
Didn't I just get 2 for that dice question?
1 for the dice question out of 2.
Oh.
You thought you were getting 2 marks for simple particle model is not pairs.
Yeah.
No.
And the hydrogen thing you said.
That was the next.
Said H.
Yeah, so you've had 2.
2 limitations. Did I not get 2 marks for that?
You only gave 1.
It's not in a pair.
Yes, that's what you said. Simple particle model is not pairs. You did not name another one. Why would you get 2 marks for that?
Sorry, I think I drifted off for a bit, and you were reading the other possible answers, and I thought they were answers I'd given.
You thought that
my mistake. I misunderstood.
Right. No, that was the mark
I think
scheme.
that's what's happened there.
You did not just rattle off 8 different correct answers.
It sounded very like me, that's all. Okay, I understand now.
7.6 was your first go back, sir, Laura. And you correctly calculated the volume of hydrogen gas at room temperature needed for a car to travel 100 kilometers, and it was 4,800 decimeters cubed. And you got 4 marks for that, which was great because you got 6 out of 12 for question 7, whereas it would have
50% though.
2 out of 12 if you hadn't gone back.
Ugh, yeah, okay.
Um,
Okay.
So then, question 8 was about the halogens. You had to work out the state of bromine at freezing point and boiling point, and that was liquid and gas. 8.2, explain the trend in boiling points of the halogens shown in table 5 for 4 marks. Boiling point gets higher with fluorines the lowest and bromines the highest because it has more electrons and because it has stronger bonds between.
So, what you saying, Ron?
So I gave you 1 out of 4. You got a mark for boiling point going up, but you didn't talk about the mass of the molecules or the size of the molecules. You didn't talk about intermolecular forces or the energy that it takes to overcome them. So it's 1 out of 4 for that one. Next one, maybe the weirdest wording so far. You can't boil a molecule. Oh, sorry. Why is it not correct to say that the boiling point of a single bromine molecule is 59 degrees? You can't boil a molecule because atoms are always never alone. The connection between the molecule defines the state. But you did get a mark for that. That was correct. The next one we were talking about why an experiment where you pass a halogen gas over iron with heat in a glass tube.
I remember being annoyed with this drawing.
It's a bit shit, isn't it? I don't like that the iron is at a different resolution to the rest of it.
It's just been a bit scribbled, hasn't it?
Yeah. They were giving up by this point.
Me too, mate.
This one I think you'll be cross about. So it was give one reason why this experiment should be done in a fume cupboard. You said halogen is dangerous to breathe. So the available answers were the gas/halogen is toxic.
Yes, that's the same.
But it also says allow the gas/halogen is poisonous/harmful. Allow to prevent inhalation of the gas.
Harmful, dangerous, synonyms.
Ignore deadly/lethal.
Inhalation. Yeah, didn't do those. Get a mark for that.
You reckon? I really wasn't sure.
Yeah, because they're saying respiration and inhale, harmful, and I've said dangerous to breathe. Those are synonyms.
All right, I'll give it to you.
Yes!
But I wasn't sure. Then you had to explain why the reactivity of halogens decreases going down the group.
Oh, I think I pulled this one out the bag, though. I remember thinking very hard about this one.
Halogens have very full outer shells and are attracting electrons to them. So as you go down the group, each element has more shells of electrons, and so the space they have available to attract an electron is further away from the protons that are the attractive for any electrons they could potentially gain. Which I did give 3 marks for.
Yes!
The outer shell, written in the mark scheme, it goes, the outer shell become further away from the nucleus. So the nucleus has less attraction for the outer electrons, so an electron is gained less easily.
You cannot even see the difference between my answer and theirs, basically, there, can you?
No, basically, word for word. 8.6 was a comebacker, and this is the one that you ended on. So you did not finish it, but you did get 1 mark. It was working out masses of iron and glass tubes and chloride and stuff, and You worked out how much iron and how much chloride there was, but you didn't get further than that. But that's fine.
Moles just keep tripping me up.
Yeah, you don't get moles, and I don't know why.
No, we need to recover that, I think.
It's just a number, like a dozen.
It's not, though, is it? Because it's ethereal.
No, it's not ethereal. It's a number. It's the number.
What number is it?
It is the number of carbon 12
12
atoms in 12 grams of carbon 12.
But that's not a number.
That is a number. It's the number of that.
So what is that number?
It's like 6.023 times 10 to the 23.
Well, let's just call it that then.
It's just called a mole.
So 1 mark there. Okay. So that's the end of question 8. That felt all right. That felt pretty good until the end. And that was a time run out, see?
Yeah. So that was 8 out of...
What did I get for 8 then?
8 out of 16.
Oh, it felt better than that.
Well...
Is that including the extra one you gave me?
You lost 5 marks on the last one. Yeah, that is including that one.
Okay.
Yeah, you lost 5 marks on the last question. The trend in boiling points one. You lost 3 marks there. You hemorrhaged marks across.
Yeah, all right.
Question 9.1, you didn't answer. It was marked to come back to, but you didn't seem to have time. It was identifying why there might be an anomalous point.
Oh, yeah, I had no idea.
No, and the answer in this is didn't stir the solution enough.
Fucking hell.
Yeah, which I feel is the kind of bullshit answer that you could have given, but you didn't.
Yeah.
Sorry, mate.
I think I specifically wrote stir it in an earlier question.
You did.
And got laughed at for it.
So the next one, explain the shape of the graph in terms of energy transfers taking place. You should use data from figure 6 in your answer. The solution begins at just shy of 17 degrees. The temperature of the solution decreases until there is 1.5 grams of citric acid in the solution. This is because citric acid and hydrogen carbonate solution have an endothermic reaction up till this quantity. Above the 1.5 mass of citric acid, the temperature begins to increase, suggesting that the citric acid and the hydrogen carbonate are now emitting energy from their reaction.
This sounds great.
Well...
Is this great? Sounds great.
You lucked yourself into 2 marks out of 3 because you did not understand what was happening. It's not that up to a certain point the reaction does one thing or it does another. It was up until that point it's doing the reaction, and then one of the reactants is all used up. So then it just starts warming. So it has an endothermic reaction, taking in energy. You correctly identified that. And then after it's all used up, then it's not doing that reaction anymore, so then it just heats up in the room. I feel like you still don't understand. I don't think you're listening. I think that donut's worn off.
It has, Ron.
Okay, but you did get 2 marks. The next one... I just wrote 3 marks. I'm sorry, I don't...
Yeah.
Question 9.4 and 9.5 you skipped. Because...
Oh, that's because it was a drawing a graphed one on 9.3, Ron, and we just get those.
Oh, yeah, you're right. But 9.4 and 9.5, yeah, you just skipped because they were about moles and titrations and stuff, which scare you deeply.
I don't know what titration is.
It's a experiment that you do.
Oh, yeah, now it's barrette time.
Yeah, it's titration's where you use a barrette. So you give 2 reasons why a barrette is used for this citric acid solution. You said because it evaporates at room temperature, so you need it in a closed transport system. Nonsense.
Okay.
Burettes aren't even closed. And then the other answer you gave was for precise measurements, which was correct. So you got 1 mark for that. And then you just didn't answer question 9.7 either, so we're done.
Oh, yeah. Got tricky. All right, what did I get at the end there?
6 out of 18.
Woof. Oh, stanky. Okay, so if I've done my maths correct then, I've got 55 out of 89. Is that what you've got?
No.
Oh, what have you got?
54, it should be out of 100. Yes, it's out of 100.
Mackie, be quiet.
So you got 54, Laura. So you actually did better than this than biology.
54. So that's 108 on the mark scheme.
Let's get the marker up.
Let's have a look. Chemistry higher tier, 108. Oh, that's just short of a 7. So that's a high 6. Which Ron, I think, is an A.
No. 6 out of 10 is an A.
Well, a 6, if you look at the new grading structure, hang on, I'll send you this link. And obviously they don't match up, so it's not like 6 is, just equates totally. They're a little bit blushy over each other. And I'm literally 4 points off a 7. And a 7 is definitely an A. So a high 6, if not a very, very high B, it's an A.
But where did you get that 54 is a 6?
Because if you look at this here, which is what we used before, and then we doubled it because these should be 2 papers. That's right, isn't it?
I think so.
Yeah, because maximum mark 200, whereas my maximum mark is 100. So 54 times 2 is 108, which is, it's a 90 for a 6 and 112 for a 7.
That feels mad that you could... Yeah, I guess. Yeah. Oh,
So it's a high 6.
so it's a B.
It's a slight argument. It's a high B.
There's
but they
literally
don't
a line
definitely
in
equate to
between
each
them.
other. Oh, but we talked about this before, Ron, about how if the numbers just fully matched up to each other, they would never have even bothered to change
But there's
it, would
literally a line.
Like, see how 6, 5, and 4 are both there?
6, 5, and 4 apply to the B and C area. That's denoted
Yeah,
by
exactly.
lines.
And it's a little
9,
bit
8, and 7.
It's a little bit squashy.
9, 8, and 7 apply to A and A star, and again denoted by a line.
Yeah. So I'm very, very close to an A.
You're very close to an A, yes, but close to an A on the
Could
B
arguably
side of
be
things.
interpreted as an A.
No,
if
it
we were
even
going to
says
be
in the
positive
text there, the
instead
bottom of a grade
rude.
7 is comparable to the bottom of the old grade A.
And I'm 4 marks off that, Ron.
Yes, you're close to it, but you did not get there.
Why can't you ever let me have anything?
You can't have things that you don't have. You got a B. That's good, isn't it?
Oh, if I just had time to go back, I could have got an A.
If you knew what oxidation was, you might have gotten an A.
Yeah, if you'd taught me what oxidation was, or titration.
Nah, we went through both of those things
Or
probably.
if I hadn't said lithium. Still, I did better on that than biology then, so far we're on the same pattern.
Yeah, so we'll see how you do for physics, which is, oh God, there's going to be so much
Yeah.
maths.
Yeah. All right. Okay, Ron.
Yeah, anywho, enjoy your day off.
If I'm totally honest, Ron, I can't remember what I got in chemistry. It was pretty much the same, wasn't it, as...
It was a number which we don't know how to interpret.
Listen, it's too New Year-ish over here for us to have actually listened back to the episode, but you just heard it, so there you go.
We're A-level legends now. We don't
Nearly.
fucking... We're leaving this GCSE shite in the past.
Well,
so who
I'm very
cares?
excited because we're about to record the physics results, and I'm quite excited about that. No spoilers, but next week physics starts. So just to give you a little rundown of what's coming up, we have got physics
Laura,
coming up.
Sorry,
obviously.
before you get into that, why are you excited for these results?
For physics,
Yeah.
I thought it went well.
Okay.
Ah. Okay, well, enjoy the next 2 weeks of my false optimism then. So we got chemistry results you just heard. You got physics coming up for the next 3 weeks. Split over 2 episodes and then the results, obviously. In the midst of that, you've got a Tentron coming out about aeroplanes. Then we're going to be doing something special, which we will announce in a couple of weeks.
Next week, no? If we record it tomorrow.
Next week. We'll be announcing next week. And then there'll be a Valentine's episode on the 10th of February. Naturally, we want to talk about some animals banging. And then A-Level will begin on the 17th of February. Who can believe we're there? Not I, said the wolf. Anything else to add, Ron?
No.
No.
Yucky, come on.
Okay. Well, go about your lives, everybody. We love you. I just got a sudden panic that the Patreon episode that was meant to go out last night didn't go out. Oh, Ron, we need to do some birthdays. Wait there while I get my phone. Everybody in the Discord's been asking about birthdays. Bear with me.
I forgot we even did that.
God. Oh. Thank you, Mystic, for making a list super tidy so I don't have to scroll through this whole thing. Legend. So, happy birthday to Kesar. Neil, I'm pretty sure your name's Neil. January 1st. He's got a birthday on New Year's Day, Ron.
Nice.
Always as old
You
as
get
the year.
to lock people in.
So, happy birthday. Happy bloody birthday. And if you want to have your birthday shout out on the podcast, then join the Patreon. Patreon.com/Lexx Education. And for the measly price of £3 a month, you can access all of our bonus extra episodes, such as Buoyancy 3, which just went out, Ron.
Yes, it's a very good value, £3.
Agreed.
There's fucking hours of content on there, and if you like our brand of nonsense, we dial it up on the Patreon.
We sure do. Oh, I'm worried that the new latest... Anyway, I'm going to do this off. Thank you very much for listening. We'll see you next week. We love you. Bye.
Pencils down.